This is the 2014 Relative Velocity Q2a. We're given three ships, X, Y, and Z. We're given the times that they are observed, their displacements, so their positions, and then their velocities. And we're asked to prove if X and Z, so we're looking at these two together, if they continue on with their uniform velocities, they'll collide. So X is observed at 2 o'clock at this position, this displacement, 2i plus 7j. So he's at 2i plus 7j. In an hour's time, we'd add on 4i plus 5j. So we're going to add on 4i plus 5j. We don't know when they're going to meet. This is what we're going to work out here. We're going to work out the time. So ship A leaves at 2, or ship X, ship Z leaves at 3, so this is an hour later. So ship X is going for 5 hours, ship Z will be going for 4 hours, so this will be 1 hour less, t minus 1. So we'll have the same for Z, so this is X. Z is going to be in the position 12i plus 9j when it's observed. 12i plus 9j. And then it's going to be an hour later, t minus 1, and its velocity is 2i plus 6j. So these will have to match, the i's and j's will have to match for them to be in the same position at the same time. So let's see, is that possible? So we're going to have 2i plus 4ti. That would have to be equal to the I component down here, 12i. Plus, we have this 2ti and then minus 2i. So that's going to leave me with 2i plus 4ti on the left will have to be equal to 10i plus 2ti on the right. So bringing the t to the left, we're going to get 2ti. That will be equal to bringing the 2i to the right, 8i. So you can see here that t will be equal to 4. So they are going to collide 4 hours after 2 o'clock, which will be 2, 4, 18, 18 in the 24-hour clock, 18 or 6 p.m. is the time of collision. And then at this instant, ship Y changes course and proceeds directly to the scene of collision at its original speed. Okay, so Y is 14:30. So up to 6 p.m. it's 3.5 hours. So its velocity is 3i plus 4j. So it's going to have moved 3.5 times this, which will be 10.5i extra and 14j extra on top of its original position, which was 6i plus 9j. So at 6 p.m. ship Y over here is in position 16.5i plus 23j. So it's going to go directly to the collision. So let's just do a little sketch here. Okay, let's work out where the collision takes place. We know t is equal to 4. So X is in position. T is 4, so we're going to have 4 4s are 16 and 2, so it's going to be 18i. And then the j component is going to be t is 4, 4 5s are 20, plus the 7 is 27j is where the collision is at. So if we do a little sketch here, 18i plus 27j, 18i plus 27j. So 16i plus 23j, if we imagine 16.5 plus 23 is here, and 18 plus 27 is here. It's just a sketch. We can use Pythagoras here to find the distance between them. So you know from all your knowledge the change in x will be this one. 16.5 to 18 is 1.5. 23 to 27 will be 4. So this distance we'll call a. A is equal to the square root of 4 squared plus 1.5 squared. That's 16 and 2.25. A is equal to the square root of 18.25, which is going to be 4.2. 272, 272, and the speed, that's the distance. The speed of y is, here's its velocity, the magnitude of 3i plus 4j, you can see straight away, is going to be 5 kilometers an hour in a straight line. So we divide 4.272 by 5, it'll give me an answer less than 1, so I'll multiply this by 60 to get this is going to be in minutes. So that's A is going to be that, so the time is going to be, it's going to give me 51 minutes for y to get there, so that will be 6:51 p.m. or 18:51.